Hi guys, welcome to Mitch Maths. My name is Mitch, and in this video we're going to be looking at some more fractions, and this time we're going to be looking at how we multiply and divide fractions together, and then we'll be looking at how we add and subtract fractions together as well. Okay, so let's get straight into multiplying some fractions then, and I've got the example right here. So we've got a really easy example to start with. We've got 1/2 multiplied by 2/3. And when we're multiplying fractions, it is really easy because all we do is we take the numerators and we times them together, and that gives us our numerator. We take the denominators and we times them together as well, and that gives us our denominator. So if we were doing that with this example, then the answer would be we would take our top two numerators, so we'd say it'd be 1 times 2, that would form our numerator, and with our denominators it'd be 2 times 3, just like this. And if we do that real quick, then we'll say 1 times 2 is 2, and we'll say 2 times 3 is 6. And that is our answer, 2/6. But of course, as we saw in the previous video, we always want to cancel down our fractions. So this would become 1/3. And it's as easy as that, guys. With multiplying fractions, you just times the top two, and then multiply the bottom two, and that gives you your answer. Okay, so I just want to run through another example as well with multiplying to show you how cancelling your fractions can help and how it can be done at any point during the problem as well. So I've got another example right here then. So this time I've got 8/15 times 5/12. So let's work this one out just like we did the last one then. So we want to do 8 times 5 over 15 times 12. So some slightly bigger numbers here, so ones which you may or may not be able to do in your head. So I'll give it a go. So we've got 8 times 5, which should be in your times tables, so that is 40. And then we have 15 by 12, which is usually slightly outside the times tables that everyone memorizes, but the way I'll do this in my head is I would take 15 and I would times it by 10 first. That gives 150. And then we've got another 2, so 15 times 2 is 30, because we just double it. So then 150 plus 30 will give us 180. And that'll be the answer to that. So that gives us our answer to this at the beginning. But of course we want to cancel this down and simplify it. So remember from the last video, we find a common multiple between the numerator and denominator. And then we divide them both by that and then get our answer. So if we think of this then, we could do this in a couple of steps. So the obvious one would be by 10. So we could divide both sides by 10, so that would give us, end up 4/18. And then of course, both of these are even, so we can halve them, and that would give us 2/9. And I think that is it. We can't simplify it anymore. So that was our final answer to this at the beginning, 2/9. Okay, so now what I want to do is run through this problem again, but this time I want to show you how cancelling down earlier in the problem may help you find your answer if you struggle with some of these larger multiples, one like this. So what we're going to do is we're going to start where we were before, the 8/15 times 5/12. And what we're going to do is we're going to take it to this next stage. So we're going to take it back to the 8/5, or 8 times 5, sorry, over 15 times 12. Because what we might want to do is cancel these down right at the very start. And if we look at 8/15 and 5/12, neither of these two fractions have any common multiples between their numerators and their denominators. So these are really, really difficult to cancel down. In fact, they can't be cancelled down. But all is not lost, because if you move on to the next stage, what you see we've done here is we've grouped them together into one fraction, 8 times 5 and 15/12. So if you think about it, when you're multiplying numbers like this, having 8 times 5 would be the exact same as having 5 times 8. So in reality, you can swap the order of these numbers. So if you did that with this then, you could have 5 times 8. 5 times 8 is 40. 8 times 5 is 40, exactly the same. Over 15 times 12, like this. And what you can effectively do is you could split these up again to give you two different fractions, and it would give you the exact same answer. And if you look now, you've now got 5 over 15 times 8 over 12. And these now do have common multiples between their numerator and denominator. So what we can now do then is simplify these separately. So 5 over 15, we know that 5 goes into both, so that will become 1 over 3. And then 8 over 12, we know that 4 goes into both, and we know that 4 goes into 8 twice, and it goes into 12 3 times. So then we have our simplified fractions, 5 over 15 and 8 over 12 now become 1 over 3 and 2 over 3. And now we can multiply these then, just like we did before. Multiply the top, 2 times 1 is 2, and 3 times 3 is 9. And as you can see, that gives us the exact same answer both ways of doing it, 2 over 9. So that shows us that it doesn't matter where we cancel the fractions down in the working out, it would always give us the same answer at the end. Okay, so moving on to dividing fractions now, and we'll start off with the exact same example as we did with multiplying, but this time dividing. So this time we've got a half divided by 2/3. And you might be tempted to follow a similar procedure like we did in multiplying, where you might say, oh, I want to do 1 divided by 2 would be the numerator, and the 2 divided by the 3 would be the denominator. But in fact, when you're dividing fractions, you actually don't have to divide at all. And what we'll do instead is we do a nice little trick where we basically flip the second fraction upside down. And then all we do is multiply it just like before. So what we'd do is we'd rewrite this as 1 over 2 multiplied by the second fraction upside down. So this would become, rather than 2 over 3, it would become 3 over 2. And then from there, now it looks just like a multiplication like we did in the previous part of the video, and we'd multiply it exactly the same way. So we'd take the 1 times 3, get rid of that, 1 times 3 is 3, over 2 times 2 is 4. And that is the answer to 1/2 divided by 2 over 3 is 3 over 4. Okay, so now let's move on to a slightly more tricky example then of dividing fractions, and this time the example I want to show you is using mixed numbers. So when dividing mixed numbers, or numbers with a fraction like this, it really helps to first convert it into just one fraction, or in this case, because it's a mixed number, it would be an improper fraction. So first of all, we need to convert these, and if you're unsure about doing that, I recommend going and checking out my previous video where we showed you how to convert between mixed numbers and improper fractions. So let's do that really quickly right now then. So first one, we've got 1 and 2/3. We'll convert that into an improper fraction, so we'll times the 3 by the 1, which is 3, plus the 2 is 5 over 3. And then the second one, we'll keep that dividing symbol, we'll say 4 times 2 is 8, plus the 1 is 9. So we've got 9 over 2. So now we've got 5 over 3 divided by 9 over 2, just these two mixed numbers represented as improper fractions. And now we'll do the exact same thing we did before. So we'll rewrite it as a multiply, and then we'll turn this fraction completely upside down. So we'll say 5 over 3 multiplied now by 2 over 9. And then we'll work this out exactly the same way. So 5 times 2 is 10, over 3 times 9 is 27. And there we go. We'll look at this and we'll think, can we cancel this down? I can't find any common multiples that, or sorry, common factors that do go into 10 and 27, so I think this is it. It can't be cancelled down. So that's our final answer. So 10 over 27 is the answer to 1 2/3 divided by 4 1/2. Okay, so now let's move on to some adding and subtracting of fractions then. And what you'll see is that this is now slightly trickier than multiplying and dividing. And the main reason for that is because what we must do to add or subtract fractions is we must find what we call a common denominator. So what I mean by that is the denominator in both fractions must be the same. So you'll see in this case it's not. We've got 2 here and 7 here as our denominators, and these must be the same. So I'll show you guys how we convert these fractions to have the same denominator. So what we must do is we must find a common multiple between our denominators, in this case 2 and 7. So we must find a common multiple of 2 and 7. So a number which both 2 and 7 will multiply into. So if you think about this really quickly, we've got 2 and 7. If we doubled 17 to 14, that is an even number, so that means that 2 will go into it. So 14 can be used as our common denominator. So if I should write out what these fractions will look like then, it will look a little bit like this. So we're not sure of our numerators yet, but we'll have our common denominator of 14. So now we need to look at how we convert these fractions to have the same value but with a denominator of 14. So the way we do that then is we think, okay, so what must we multiply this denominator by to get our new denominator? So what do we multiply 2 by to get 14? And of course we know this is 7. 2 times 7 is 14. So because we've multiplied 2 by 7 to get 14, we must also multiply our numerator by 7 as well. So 7 times 1 is 7. So we must write 7 there as our new numerator. So the reason for this is because if we think about a fraction and think about what value it is, we can think of fractions like a ratio, and the ratio must be maintained to give the fraction the same value. So multiplying top and bottom by the same number will keep the same ratio and keep the same value. So 1/2 is an equivalent ratio to 7 over 14. Okay, so let's now do the same thing with our second fraction. So we have 7 over 5, 5 over 7, sorry. So what number do we multiply 7 by to get 14? So we know we double it, so we times it by 2. So we must also times our numerator by 2 as well. So 5 times 2 is 10. And 10 over 14 is our new fraction here, which is equivalent to 5 over 7. Okay, so now we have two fractions with a common denominator. So what we'll then do is when we add fractions, we only add or subtract the top row, so only the numerators. We must keep the denominators the same. So 14 will stay the same, and this essentially then becomes 7 plus 10. And 7 plus 10 is 17, so that then becomes our answer. Okay, you can't simplify this down, I don't think. No, I don't think we can. So this is our final answer, 17 over 14. And of course this is actually a mixed number, so we could convert that into a mixed number to make it look a little bit better. So how many times does 14 go into 17? Just the once. And what's our remainder? 3. So 3 over 14 is our remainder. Okay, so I hope that made sense. So the main things to remember when adding or subtracting fractions is you need a common denominator. You must convert these to equivalent fractions with the same denominator, and then you only add or subtract the numerators to get your final answer. And that's it. Okay, so now we're going to look at subtracting, and I'm going to show you how the previous method we used for addition works exactly the same way for subtraction. And this time I've started off some mixed numbers to show you how it works from this point of view as well. So just like for multiplying and dividing, when we have mixed numbers to start with, it really helps to convert these into improper fractions. So what we'll do this really quickly then. So 2 and 2/5 will become, so your 5 times 2 is 10, plus the 2 becomes 12. So 12/5 minus 3 times the 1 is 3, plus the 1 is 4. 4 over 3. Okay, so now we've converted them into mixed numbers. We'll now look at what common denominators we can have. So we want a number which 5 and 3 will both go into. So let's think 5, 10, no, 15, yes. So this will then become two fractions that are both over 15. And we'll think, what do we times the 5 by to get 15? It was by 3. So we must also times the top number by 3 as well. So 12 times 3 is 36. And then what do we times 3 by to get 15? And that is by 5, so we must times the top number by 5 as well. So 4 times 5 is 20. So now, just like when we did addition, we keep the denominator the same, and we only take the top ones into account. So this now becomes 36 minus 20, and that is 16. And that is our answer. That's our final answer to 2 2/5 minus 1 1/3 is 16 over 15. And this is also a improper fraction as well, because the top number is bigger. So we'll convert that into a mixed number. How many times does 15 go into 16? Just the once, and the remainder of 1. So 1 1/15 is our final answer. Okay guys, I really hope this whole video made sense on multiplying, dividing, adding and subtracting fractions. I hope you enjoyed that video, and if you want to see more, then head over to my YouTube channel, and I'll be putting this on my website as well. And thank you for watching, and see you in the next video. So thank you very much.